Bismillahirrahmanirrahim. Welcome to this lecture. We already have studied this example, logical example, in a previous class, but here I will record this lecture and we will solve it step by step. So here is the logical problem. Does the Superman exist? There are certain prepositions. If Superman were able to willing to prevent evil, he would do so. If Superman were able to prevent evil, he would be incapable. If he were unwilling to prevent evil, he would be malevolent. Superman does not prevent evil. If Superman exists, he is neither incapable nor malevolent. Therefore, Superman does not exist. So now we will write these prepositions. For example, Superman exists is equal to X. We represent that with X. Superman is willing to prevent evil. We represent that in W. All of these propositions are from the statement given above. Superman is able to prevent evil. We represent that with A. Superman is malevolent, represent with M. Superman is incapable, we represent this proposition with I. Superman prevents evil, we represent that in with E, represent that with E. Now we will write it our objective is to prove the preposition, for example. So here E is Superman prevents evil. If Superman is willing and able to prevent the evils, then it implies these. If these two are true, then it implies that Superman prevent evils. And not A. If Superman is not able to prevent evil, so he would be malevolent. He would be incapable. Here you can see he would be incapable. So this is represented here. And if he were unwilling to prevent evil, he would be malevolent. So not W, W willing, not willing to prevent the evils, so malevolent. And not E, Superman prevents evil. If and not E, Superman does not prevent evil. So we have written it here. And if X exists, then he is not incapable or malevolent. But we have to prove that Superman does not exist. So again, no, we have to assume these all, and the objective is now to prove not X. So here now we will start from the opposite or contradiction. Here we have that Superman does not exist, but we will assume X. We will assume that Superman exists. So no, we will try to show that. We will try to show contradict it, that Superman does not exist. Now here we will start use elimination rule to break number 1 down into 5 premises. So here in the last lecture, if you have heard that there is an elimination rule, so we will look into these elimination rules, so how it works. So one of the elimination rule is P implies Q. We got Q, and another elimination rule is PRQ. So we have got PRQ. So here here what we will let me bring the elimination rule for AND. So then, because we have breakdown using an AND elimination rule, so I have brought here an AND elimination rule. So if we look into this, these statements are separated by AND. So from AND, if we have P and Q, then we eliminate either Q or P. So here if we look at this, W and A implies E, so we have only consider this statement, and all these statements are connected by AND. So we have eliminated all those statements. So again we will then consider this statement, the fourth one is this statement, and all the other statements we will eliminate, and then the same for all these. So here we have eliminated all the other propositions, and we have break down that into 5 propositions. Now we have to look this x these are the rules which we have break down. Now application of elimination on 2 and 7 derives another simple proposition. What this means: 2 we have assumed x, and 7 we have x implies not I or M. Now here we can we also apply an elimination rule, P implies Q. So P implies Q, so we can get Q from it. So here 8 we have got Q from it, and Q is equal to not I or M. No, not I or M. No, if proving I or M will results in contradiction. What this means? No, we have proved that not I or not M. Now proving I or M will result in contradiction. What this means, that we have proved that I not I or not M, agar if we have to prove that it exists, so it will be contradiction to the I or M. Now we will analyze W. So assume not W. So if we see we see this W, not W. Not W implies M. So if we assume not W, so it will result in M. And from 5 and 9, 9 is not W and 5 is not W implies M. So elimination rule, P implies Q, so we have got M. I know we can also from the R rule, if we have only one P, we can assume PRQ, or if we have P, we introduce PRQ. So we have M, so we can introduce 1RM. Now we have to go to assume the contradiction of W. So assume W and assume A. So we have W and A, and from this W and A we can eliminate, we can conclude Q. We will eliminate W and A. So here we can we have to conclude E. So E has been concluded. No, we have an assumption not E. So E not E, it will be equal to false. If you look at this, P not P, it will be equal to false. Again we have IRM. Assume not A. Not A, when we assume not A, it give us I, means that incapable. So here we have got this as a false. If we look back in here at 11 I, or we have got M here, and if M is true, then IRM is true, that is from the introduction. And here if we look at this, if this is true, then we have got one contradiction, and that contradicts the contradicts number 8, which tells that not IRM. Okay, so here again we have come to this point, false. We have concluded that it is false. Now we have I and RM. From 16, from false we can conclude anything. From false we can conclude anything in from the elimination rule. So we have conclude IRM. So again this is a contradiction to the to rule number 8 which we have written. So here we will now assume not A. If we look at not A, we got I. So again from this we conclude IRM, this introduction. And from 17 we have got IRM, and from 11 when we assume not W, we have got IRM, and from 17 we have, when we assume W, we have got IRM. So this is false, this is contradiction with number 8, so it is false. So from this we conclude that not X, that X does not exist. So thank you.